morning, ladies and gentlemen. Today I'm going to discuss the dangerous effects of the use of nuclear power on the Earth's environment. Now, in the minds of many, this may not be a pressing issue or even the most prominent concern regarding nuclear power. When people imagine the dangers of nuclear power, they most likely picture a nuclear war scenario or a nation with terrorist ties launching nuclear warheads. When people consider what is most threatening to the environment, they most frequently think of the concerns surrounding global warming and the dangers of pollution. However, in the world we live in today, nuclear energy has the potential to be just as, if not more, destructive to the Earth and its inhabitants around the world. Nuclear power was first developed following World War II, and the first recorded event of a nuclear reactor providing electricity occurred on December 20th, 1951, at the EBR-1 experimental station near Arco, Idaho. The initial reaction generated only approximately 100 kilowatts and powered a few high-energy light bulbs. This breakthrough led to the development of nuclear reactions thousands of times more powerful. The first reaction produced literally a decimal percentage of what nuclear reactors are now capable of producing. As time progressed, nuclear power progressed as well. Today, the power of nuclear reactors is much greater and therefore much more dangerous. The principal risks associated with nuclear power arise from health effects of radiation. This radiation consists of subatomic particles traveling at or near the velocity of light, 186,000 miles per second. They can penetrate deep inside the human body, where they can damage biological cells and thereby initiate a cancer. If they strike sex cells, they can cause genetic diseases and progeny. Radiation occurs naturally in our environment. A typical person is and always has been struck by 15,000 particles of radiation every second from natural sources. And an average medical X-ray involves being struck by 100 billion. While this may seem to be very dangerous, it is not, because of the probability for a particle of radiation entering the human body to cause a cancer or genetic disease is only 1 in 30 million billion, or 30 quintillion. Nuclear power technology produces materials that are active in emitting radiation and are therefore called radioactive. These materials can come into contact with people principally through small releases during routine plant operation. Accidents in nuclear power plants, accidents in transporting radioactive materials, and escape of radioactive waste from confinement systems. All of these taken together with accidents treated probabilistically will eventually expose the average American to about 0.2% of his exposure from natural radiation. Since natural radiation is estimated to cause about 1% of all cancers, radiation due to nuclear technology should eventually increase our cancer risk by 0.002%, or 1 in 50,000, reducing our life expectancy by less than 1 hour. By comparison, our loss of life expectancy from competitive electric generation technologies, burning coal, oil, or gas, is estimated to range from 3 to 40 days. Reactor accidents. Risks from reactor accidents are estimated by the rapidly developing science of probabilistic risk analysis. A PRA must be done separately for each power plant at a cost of $5 million, but we give typical results here. A fuel meltdown might be expected once in 20,000 years of reactor operation. In 2 out of 3 meltdowns, there would be no deaths. In 1 out of 5, there would be over 1,000 deaths. And in 1 out of 100,000, there would be 50,000 deaths. The average for all meltdowns would be 400 deaths. Since air pollution from coal burning is estimated to be causing 10,000 deaths per year, there would have to be 25 meltdowns each year for nuclear power to be as dangerous as coal burning. Very high radiation doses can destroy body functions and lead to death within 60 days. But such noticeable deaths would be expected in only 2% of reactor meltdown accidents. There would be over 100 in 0.2% of meltdowns, and 3,500 in 1 out of 100,000 meltdowns. To date, the largest number of noticeable deaths from coal burning was in an air pollution incident, where there were 3,500 extra deaths in 1 week. Of course, the nuclear accidents are hypothetical, and there are many much worse hypothetical accidents in other electrically generated technologies. For example, there are hydroelectric dams in California whose sudden failure could cause 200,000 deaths. Radioactive waste. The radioactive waste products from the nuclear industry may be isolated from contact with people for very long time periods. The bulk of radioactivity is contained in the spent fuel, which is quite small in volume and therefore easily handled with great care. This high-level waste will be converted to a rock life form and placed in the natural habitat of rocks deep underground. The average lifetime of rock in that environment is 1 billion years. If the waste behaves like other rock, it is easily shown that the waste generated by one nuclear power plant will eventually, over millions of years, if there is no cure found for cancer, cause 1 death from 50 years of operation. By comparison, the waste from coal burning plants that end up in the ground will eventually cause several thousand deaths from generating the same amount of electricity. The much larger volume of much less radioactive waste from the nuclear plants will be buried at shallow depths, typically 20 feet in soil. If we assume that this material immediately becomes dispersed to the soil between the surface and groundwater depth and behaves like the same materials that are present naturally in soil, the death toll from this low-level waste would be 5% from that high-level waste discussed in the previous paragraph. As you can see, radioactive waste is dangerous in comparison to the other sources of pollution that plague our Earth.